What's up, guys? So I feel that my game engine has enough features that is now usable. For the past 6 months, I actually been working on adding a lot of post-processing effects. Gizmo tool, I improved the editor, and I even added a console log, which I'm very happy that I actually added that. But now, all of these features are great, but performance-wise, not that great. And that is because throughout this whole time of development, I haven't really focused on performance, on improving the shader's performance at all. But now, it's time to fix that, because what use is of a game engine if it doesn't run fast? So I decided that for the past, next month, 6 months, I'm going to be working on performance. And the first rendering pass that I decided to focus on was on the light pass. Simply because when I profiled the engine, that particular pass just caught my attention right away, and I figure, what, let's fix that. So for those who are new to computer graphics and do not know what a light pass is, basically my game engine is a rendering. My game engine uses a defer rendering architecture, which means that I have a geometry path which deals with all of the vertices of the models, and then that particular path will produce 3 to 4 different textures or targets that has information about my color or albedo, normals, and positions, and I also pass emissive information. Now in the light pass, I take all of those textures and I apply lighting information, and that's basically that's basically what a defer renderer is. It uses 2 different passes, a geometry and a light pass. So I decided to profile my light pass, and what I did was simply I loaded up a scene which has over, I believe, if this works, has over 214,000 vertices. It's not a lot, but it's enough that I can actually put the engine under a bit of pressure. So I profiled this particular scene, and when I went in to look into the counters, some of the things that stood out were that some of the limiters were the arithmetic logic unit, the texture read, and the MMU limiter. The numbers are shown on the screen, and I'm going to highlight them for you. But as you can see, my biggest limiter right now is my texture read limiter with 57.8%. Now, don't ask me why, but I decided not to focus on that during the I decided not to focus that first. I decided to work on the MMU limiter first. In hindsight, I should have used the texture read first, but no, made that mistake. Well, so what did I do to actually improve the MMU limiter? Well, my first idea was, why don't we use some buffer preloading? Basically, the whole idea is to combine related data into a single buffer. Previously, I was sending light data into different buffers. As you can see here, I was sending in one buffer my point light attributes, such as intensity, radius, etc. And in another buffer, I was sending the point count. And that's not really a good idea. You want all of your data to be in a contiguous format, so that way the GPU can just fetch them right away. So what I did was I modified my code, and I loaded all of that information into one single structure, such as what you see here, point light block, and that actually improved the performance. We went from 32.19 to 26.43 just by doing that simple modifications to the code. Then what I did next was, let's focus on the texture read optimization. Let's see how I can optimize this. Now, one of the simplest thing that I did was instead of using sample to sample my texture, I decided to use read. And why? Well, when you sample, you do a bit more math, such as mapping and filtering. Whereas when you use read, you simply fetch the pixel right directly. So that will help you with performance. And just like what I have here, right? I have, before I was using my sample, and then afterwards I decided to use read instead. And by simply doing that, my limiter for my texture read went from 57.8 to 46.7, which is good. And my utilization went up by 4%. Well, 3.2%. But, that's actually quite good, right? Then I figure, hey, you know what? I'm sending a bunch of textures from my geometry pass to my light pass. What if I reduce my resolution for all of those textures? Initially, my textures were this is wrong. Initially, my textures were from float, and I decided to change them to half. Actually, here in the screen it should be reversed, but you get the point. Basically, I reduced the resolution by half, and to my surprise, and this is a real surprise, my numbers actually did not improve at all. They actually reverted. My limiter went from 46.7 to 56, and my utilization went from 30 to 32.3%. That was shocking because I thought that I was going to see a huge improvement, but no. So maybe there is some alignment issues going on. Maybe, I don't know. Using read is not the proper thing to do when we reduce the resolution. I'm just thinking that out loud. I do not know, but this was very surprising. And if you happen to know why this happened, if you have come across this before, let me know in the comments, because I am really curious about why reducing the resolution of my textures did not help at all. So next, what I did, well, you know what? Let's see if we can improve the ALU limiter, the arithmetic logic unit. And as of last week, all of the mathematics in my shaders were using floats, all of them. So the idea is to reduce the resolution in operations that are not so critical, right? So instead of using floats, you can use halves. And that's what I did. What I decided to do is that when I'm computing my lighting contribution in my BRDF, anything that is related to that diffuse contribution, I'm going to use half. And anything that is related to my specular contribution, I use float. I did an experiment where I used half for both of them, and trust me, the image just looked awful. So yeah, don't do that. So after doing this, what did I get? Well, my limiter went from 49.4 to 37.5. My utilization went from 45 to 35. My F32 decreased, which is what I was hoping. And unfortunately, my half mathematics utilization only increased by 1.1%, which is not what I wanted to see. But okay, So these are my final numbers, right? My GPU time for that particular pass went from 2.53 milliseconds to 0.31, which means it's like 8.7% faster. My texture read limiter did decrease from 57.8 to 50.9, which is 12% less limiting, which is good. My MMAU limiter, I gained basically 27% less limiting. My LAU was flat, F32 was down, and my F16 was negligible. So what do the numbers say, right? Well, I was able to shave off around 9% of the pass. It's not a huge improvement, but I was able to improve it. The biggest wins came from me, dropping the MMU limiting. That was the biggest win. My arithmetic logic unit stayed flat, and my half precision register didn't really move at all. So what am I going to do next? Well, I'm going to keep improving the performance. I'm going to keep digging in. But this was really, shocking. I was hoping to see better improvement, but it didn't. But that's okay, because the whole point is for me and you to learn. And I'm going to keep digging. So if you want to, subscribe and see my next video, because I'm going to hopefully improve my light pass. But I also want to go and improve my shading, my shadow pass, which is awful as well. That pass needs a lot of work. So yes, for the next 6 months, I'm going to be working on improving performance. So if you want to learn along with me, subscribe to that, and then click like on this button. And please write some comments, because I am not an expert when it comes to performance optimization. So if you have some good bit of knowledge that you want to share with me, let me know. I'll be really thankful. And I'll see you guys next time.